The Plaza. We are doing a review for college algebra, test number 4. First question. We has been asked to find the real zeros from this function. In order to find the real zeros, we have to equal every x, every parenthesis to 0. X plus 3 equals to 0. We have to add 5, both sides of the equal sign. 5 cancel with 5. Okay, a minus 5. So 5 cancel. Now we have x equals 5. Here, negative 3, we subtract 3, both sides of the equal sign. 3 cancel. Now we have x equals to negative 3. So our real zeros are negative 3, 5. Now for b, they want us to find the multiplicity. The multiplicity is given by the exponent. At 5, we have multiplicity of 2, and at negative 3, we have multiplicity of 3. Now, letter C. They asking us whether the graph touches or crosses. We're going to figure out the touching or crossing by the exponent as well. An odd exponent is going to be crossing. So it crosses at negative 3. When we have an even exponent, it's going to touch. So it's touching at 5. Now for letter D, we have to give out the ending behavior. Because it's a positive, the leading coefficient is positive, it's going to be up. And up at the end as well, because we have even coefficient, positive, we have a positive leading term, and we have an even exponent, the higher. For letter D, overall end behavior. We're going to get the end behavior by the exponents. If we have 3 here, that means we're going to have 3x's at the end. And here we're going to have 2. When we multiply variables, we add exponents. So at the end, we're going to have 2 plus 3 is going to be 5. That means we have an odd degree. An odd degree, and the leading coefficient is positive. So positive leading coefficient and an odd degree, that means it's going to be up and down. Now we're going to go to question number 2. They are asking to construct a polynomial function that might have the given graph below. In this problem, we're going to go backwards. We're going to find from the graph the points where it is intersecting or touching. So is an x, our x's are going to be -2, 1, and 3. Those are our real zeros. So from here, we are gonna take this each one back if we were factoring. So we're gonna add 2 in both sizes. This cancel. Now we have x plus 2 equals to 0. And that is the same as having x plus 2. We're gonna do the same thing with the 1. We have x to be equals to 1. Now we're gonna add 1. Subtract 1 in each side of the equal sign. So we're going to have -1, -1, and that cancels. So we have x -1 equals to 0. And inside the parentheses now we have x is equals to 3. We subtract 3 in both sizes of the equal sign. The 3 cancel. Now we have x minus 3 equals to 0, and that is the same as x -3 in parentheses. And they asking us to use the function symbol f of x. So that is going to be equals to x plus 2, x minus 1, open parentheses, x minus 3. Now to figure out our exponents, we have to look at here. If it is crossing, that means we have an odd exponent. So we're going to do 1. Here at 1 is crossing, so it has to be an odd exponent. And at 3 is only touching, so we're going to have 2. A way to know your exponents, to help you figure out, you can think about the turning points. We have 1, 2, 3 turning points. Where we get our turning points from? It has to be the higher number, the degree, the higher degree, minus 1. That gives you your turning points. If we have 3 turning points, I'm guessing we have 4 as a maximum exponent, the highest exponent, minus 1 equals to 3. So that gives me an idea that what I did here, I decided to use 1, 1, and 2 is the right number. That will be 4 minus 1, 3. So my final, just to clean it up a little bit, because we really do not use, we don't write the 1 as an exponent. So this will be your final answer. Question number 3. List the intercepts and graph the polynomial function. We're going to find our intercepts by finding our real zeros. So the first x, we're going to equal that to 0, and that is going to be one of our intercepts. Then we have x plus 4 equals to 0. So we're going to subtract 4 in each side of the equal sign. 4 cancel. Now we have x equals -4, and we have x minus 3 equals to 0. We add 3 both sizes of the equal sign. Cancel. Now we have x equals 3. So x-intercept, we have 0, as I do in order, it should be negative 4, 0, 3. The points for that is going to be 0, 0, x equals negative 4, and y is 0, and x equals to 3, and y equals to 0, because those are our x-intercepts. I know my y-intercept is going to be here. 0, 0 is going to be crossing through the origin, but if you want to double check that if you have a different number, the way to do it is when you're looking for the y-intercept, you equal x to 0. If you equal all your x's to 0, you're going to have y equals 0, 0 plus 4, parentheses, x minus 3, oops, it should be 0 minus 3, raised to the second power. So y equals 0, here you're going to have 4, here you're going to have negative 3 times a negative 3 is going to be 9. If you multiply those two, you're going to get 36. I'm just doing it to show you. And then at the end, you multiply 0 times 36, which is going to give you 0. So 0 for your x value, 0 for your y value. That's going to be this point. It's x and y intercept. How to know the direction where your graph is going to come. So we need to count our exponents, our x's. So we have 2 x's here, 1 x here, so it's 3, and 4 with this x. We have to take care of that one too. So the degree of our polynomial is 4, which is an even number. And the leading coefficient is positive. So leading coefficient is positive. That means the end behavior is going to be up and up. So that gives us an idea that the graph is going to come from here. I'm not good at drawing. You're trying to do a better job than me. And it's going to cross because we have an odd exponent. It's going to be crossing. So it's going to cross a negative 4. Somewhere around here, it's going to go up again, and it's going to be crossing right through the origin. And then, after it goes up, it will go down again, and it's only going to be touching at 3 because our exponent is even. So it will touch at 3, and it will go up again. So our end behavior is up, up. Here, it should be touching. Let me make it look like it's touching. Okay. Horrible drawing, but at least you got the idea how to figure out more or less the shape of your graph. Question number 4. We're going to be graphing this function, and we have to describe our steps. So we're going to start for the easy part. Because we have inside the parentheses a -1, when we have any grouping symbol, we know there is going to be contra logic. So we're going to shift right 1 unit. I said contra logic because you see the negative and you will think that you need to go to the -1. But no, we're going to be on +1. Or we're thinking that our functions are going to start in the origin. From the origin, which is here 0, 0, we're going to move 1. And that comes from this parentheses x minus 1. Now, our second step is going to be a stretch by the factor of 40 because we are dividing by 40. Means I'm gonna really stretch it. So it's gonna be that is coming from here, 40 x minus 1 square. The second step that we're gonna describe is gonna be shifted down by 10. Every time we have a number that is outside of any grouping symbol, generally it's gonna be our constant, is the last number at the end to the right. That one is gonna go with the logic. As you see negative 10, we're gonna go down 10. So outside any grouping symbol is gonna go left and right. That means in our x-axis we're gonna go up, I'm sorry, anything that is outside any grouping symbol is gonna go up and down in the y-axis. Anything that is inside a grouping symbol is gonna be contra logic, and we're gonna move it in our x-axis. If we see a negative, we're gonna go to the positive side. If we have a positive number, we're gonna go to the negative. So now we complete our function is 40 over parentheses x minus 1 squared minus 10. So we describe step by step what we're going to be doing with a function using transformation. Now to find our axis of symmetry or vertical asymptote, it will be the same way. We are going to take our denominator to find the vertical asymptote, and we're gonna solve for x. When we have this square here, that means that we have two parentheses that are the same. We're gonna FOIL, so x times x, x times negative 1 times x, negative 1 times negative 1. So we're going to have x times x is x squared, negative 1 times x is negative 1x, negative 1, x times x is going to be negative 1, negative 1 times a negative 1 give me a positive 1. Now I'm going to combine like terms, which are these two, is a 1 here. So that means I'm going to have x squared minus 2x plus 1. As I solve this, I'm going back here. I just did it because I'm going to need it later. So I have this already done. What we have to do is take one of the parentheses, equals that to 0, and solve for it. Plus 1, plus 1. Now we're going to have x equals 1. And this is my vertical asymptote, and it's going to be at the same time my axis of symmetry. That means our graph is not going to cross this line. If the graph touches this line, is going to become 0, is undefined. So that doesn't work. That's what we figure out. It's right there. Okay. Vertical asymptote. And it's right here. Vertical asymptote at x equals 1. Now we're going to find our horizontal asymptote. I'm going to do this one in green. Horizontal asymptote. I'm going to take this that I already solved So when we looking for our horizontal asymptote, we have to find the two leading coefficients for the numerator and the denominator, so we can know if we will have a vertical and horizontal asymptote or no. We need to find the degree, the denominator and the degree of the denominator. For that, I'm gonna work this function out. Okay, that's what I was talking about before. Right now I need to use this already solved factoring this trinomial to x plus 1. So we're gonna combine these two fractions. Remember that we have a -1 here as the denominator. So in order for me to add or subtract fractions, we have to have the same denominator. So I'm gonna use the trinomial of the first fraction, the denominator, and then I need to distribute that with a -10, and I need to do that top and bottom. So x squared -2x plus 1. So I have the function of x equals to, I don't want to do anything to the first fraction because it has the denominator that I'm looking for. So now I'm going to distribute the -10. -10 times x squared is going to be -10 x squared. Then -10 times -2x is going to give me a positive 20x. -10 times a positive 1 is going to give me a -10. All this is going to be over the same trinomial, because anything multiplied by 1 is going to give you the same thing. I don't actually need that parenthesis. X squared minus 2x plus 1. Now that I have the same denominator, I'm going to combine the top. So we have to look for our common factors. And I need to write them in a descending order. So first term, they have the highest degree, which is this one. It doesn't have any, we don't have any other x squared. Then I have only one x to the first power, and I have two constants here. So I'm gonna combine them. I'm gonna start writing my function again. F of x equals to, as I said, I'm gonna start by my highest degree, -10 x to the second power, and then I need my plus 20x. And then I'm going to combine the constants, which is 40 minus 10 is going to give me a positive 30. All this is going to be over the denominator. Okay. Now to find the horizontal asymptote, we have the same degree, so what we need is to divide by the leading coefficients. Remember that we have a 1 here, so this is going to be, our leading coefficient is going to be -10 over 1, which is equals to -10. So our horizontal asymptote is y equals -10. And we're gonna sketch that. Right here. We have the horizontal asymptote at -10. Now we're going to find our y-intercept. In order to do that, we need to equal x to 0. So we're going to write our function of 0. That is going to be 40 over 0 minus 1 raised to the second power minus 10. So keep everything organized. Function of 0, 40. I cannot do anything to the top right now, so I'm going to take care of the bottom. We have to clean this up. 0 minus negative 1 minus 1 is going to be negative 1, and that is raised to the second power. Negative 1 times a negative 1 is going to be 1. Minus 10. We always remember to have a 1 here, so we have two fractions with the same denominator. That means that we can combine them. We have 40 minus 10, which is going to be 30. That means that our y-intercept is 0, 30. Find that in the graph, is going to be right here. We have 40, 20 right in the middle is going to be our y-intercept. Now we are going to look for our x-intercept. We have more than one. So x-intercept. In order to do that, we need to equals y to 0. So now we're going to have 0 for y, and that is going to be equals. We're going to use the extended form, not the factor form. We're going to use this one that we work it out already, and the denominator in the extended form, no factor form. So I'm going to rewrite it. It's negative 10 x squared plus 20x plus 30 all that over x squared minus 2x plus 1 . In order for me to factor, I need to change this first negative sign. I don't like to have my leading coefficient as a negative, so what I'm going to do is I'm going to multiply everything by a negative 1. So I distribute the negative 1 and multiply everything just to change the first term as a positive. So negative 1 times a negative times a negative is going to give me a positive, so I have 10x squared. Negative times a positive is going to give me negative 20x. Negative times a positive is going to give me negative 30. Now I'm going to factor this, open a set of parentheses, factors of 10, it's going to be 1 and 10, 2 and 5, factors of 30, remember trying to match the negative 20 that is here in the middle. 30 is going to be 1 times 30, 2 times 15, 3 times 10, 4 is not a factor, 5 times 6, and that's all. Since I'm trying to match a positive 20x, I'm not going to multiply it by such a huge number like 30 because it's going to give me something really big. 15 I think is too large, 10 as well, 3. So I'm going to try with the smallest factors for each number. So I have factors of 10. I'm going to try 2 and 5, and here 5x. To figure out the first sign, I bring down negative. I bring it down the first one, and then to figure out the second sign, I multiply negative times a negative, give me positive. Factors of 30. I think if we use this 6 here and 5 here, that will work out. I'm going to show you my shortcut how to figure out if my factoring is correct. I multiply inners, that gives me a negative 30x. I multiply outers, that gives me a positive 10x. Because the signs are different, I subtract, keep the sign of the largest number, that gives me negative 20x. If we don't get the right factoring, if this number matches here, the middle term, that means our factoring is correct. Now the denominator, we factored this already before, but just to keep everything together and organized, I'm gonna rewrite it. We are factoring the denominator, right? Factors of x squared is gonna be x and x. Bring down the first sign, which is negative. Negative times a positive is a negative. Factors of 1 is gonna be 1 and 1. The two parentheses are exactly the same, so I don't need to do much. Just equals one of them to 0, and I'm gonna add 1 in each side of the equal sign. This is gonna cancel. Now I have x equals 1. I'm gonna do the same thing with a numerator. I'm gonna take one of the parentheses and equals that to 0. I'm gonna add 6 in both sides of the equal sign. That cancels. Now I have 2x equals 6. Now I'm gonna divide by 2. Divide by 2. 2 cancel. Now I have x equals to positive 3. The other parenthesis is right here, and I'm gonna equals that to 0. 5x plus 5 equals to 0. I subtract 5, both sides of the equal sign. 5 cancel. Now I have 5x equals negative 5. Now I need to divide by 5, both sides of the equal sign. 5 cancel. Now I have x equals negative 1. So my x-intercept, I have three x-intercepts. So x-intercept given as a point is going to be 3, 0. Remember, this is your x and this is your y. X equals 1, so that means it's going to be 1 and 0. Remember that y equals y to 0, so every y is going to be 0. Now this one is going to give me negative 1 for x and 0 for y. So here I have all my x-intercepts, and this is my y-intercept, which I plugged in the graph already. Now I'm going to mark all these 3 in the graph. I have 3, 1, and negative 1. I'm going to keep using red. 3, negative 1. The denominator, remember, that is here at 1, and that's the line, is the point that we cannot touch. It's our vertical asymptote. So more or less a graph. We're gonna do a rough sketch. Really rough, because I'm not good at drawing on this. So I'm gonna try my best. I cannot pass the horizontal asymptote, but I can get really close, and I cannot cross my vertical asymptote, but I can get really close to it. And I have my intersection. So we're gonna imagine that we're coming from down here really close to the horizontal asymptote, and I'm gonna cross through negative 1, and then through 0, which is my y-intercept, and I'm gonna get really close to my vertical asymptote, but I'm never gonna touch it. Oh, really ugly graph. I'm gonna do the same thing here. I'm coming from really close to the horizontal asymptote. I cross at 3, which is my x-intercept, and I'm gonna get really close to the vertical asymptote, but I'm never gonna cross it. Sorry for such an ugly graph, but that's the best that I can do with a smart board. So here you have a step by step what we need to do. Transformation. You have a step 1, 2, 3. We find vertical asymptote, horizontal asymptote, y-intercept, and x-intercept. Now we're gonna go to question number 5. Question number 5 is to find the vertical asymptote. We are going to be looking at the denominator. So we're going to take the denominator, we're going to rewrite it, and we're going to factor. We're going to find our x's. So factors of x squared is going to be x and x. We bring down the first sign to figure out the second sign. We'll multiply negative times negative, give me positive. Factors of 12. We have 1, 12, 2, 6, 3, 4. Right here, because the signs are different, I know that we need to subtract. So 4 minus 3 is going to give me 1. So I need the higher factor first because I need to match the sign, and then 3. I equal each parenthesis to 0. So I add 4, both sides of the equal sign. This cancel. So I'm going to have that x is equals to 4. Now the other parenthesis, x plus 3 equals to 0. Subtract 3 in both sides of the equal sign. Cancel. Now I have x equals to negative 3. So my vertical asymptote is x equals 4, x equals negative 3. Question number 6, horizontal asymptote. Here we need to look at the leading coefficient. If we have the two exponents, the degree of each polynomial to be the same, we only care about the leading coefficient. So that means y equals, the 2 is negative, so it's going to be 3 over 2. If our leading term, remember that it has to be from the highest degree to the lowest in descendant order. This one they put it backwards on purpose, I guess. So you have to really look for it. If the exponents are the same, the highest exponents are the same, you look at the leading coefficient, you divide them. This one you cannot simplify evenly. It's not going to give you a nice whole number. So you will leave it just like that. That's for the horizontal asymptote. Now in question number 7, they're asking for the oblique asymptote. We have here a 1 and here a 2. The numerator is higher by 1 number, and we're looking for the oblique asymptote. So we have to do a long division. So we're going to set our division 2x x squared plus 3x plus 4. Which number we need to multiply? Remember here always is a 1 to get a 2. So it's going to be 2. We multiply in 2 times 1 is 2. Now we have only one x. By how many x's do we need to multiply to get x squared? Only x. So x times x is going to give me x squared. Remember, always we need to find the opposite sign, because at the end we need to distribute that negative sign outside. That's just a rule that we have to follow. Now 2 times 5 give me a positive 10. It doesn't have x, so it's going to be x. Now distribute the negative. It's going to be negative times a positive, negative, negative times a positive. This is going to be really a negative. So now the whole idea was to cancel the first term, and that happens, so we're good. Here, different signs, we subtract, give the sign of the largest number. 10 minus 3 is going to give me 7x. Bring down the next term, which is 4. Now we need to figure out by which number we need to multiply by the first term, so we can get it 7. That is going to be 7, because 7 times 1 is going to give me 7. And 1 times x is going to be just x. Remember that we always have to take care of the sign. We're going to be distributing a negative 1 at the end. If I distribute here the negative, it's going to give me a negative, so I cannot cancel. So really my 7 here has to be a negative. So negative times a positive give me a negative. And when I distribute the sign, I changed the wrong one. When I distribute the sign negative times a negative, it's going to give me a positive. That's what I'm looking for, because I need them to be the opposite. Now, I need to multiply negative 7 times 5. That is going to give me a negative 35. The first term cancel. That's what I was looking for, so good. Different signs, subtract, get the sign of the largest number. That is going to give me 31. So my answer is going to be y equals 2x minus 7. Now question number 4. Solve the inequality. So we're going to rewrite our inequality and we're going to factor. Only 3. We have here a polynomial. We have 4 terms, so we have to factor by grouping. We're going to break it in half, and then they're going to find the greatest common factor of each binomial. So here we have x squared. The 2 x's that are here are going to cancel 2 x's from here. We're going to still have 1 x left over. So we have x, the 2 x's cancel the 2 x's, and they're going to have 1. Any number divided or anything divided by itself is going to give you 1. Now in this binomial I have a negative 9 as a common factor. It's I divide by negative 9, both sizes. Negative 9 cancel with a negative 9, so I'm going to have x. Negative times a positive is going to give me negative. 9 divided by 9 is going to be 1. Our checking point is going to be if our two parentheses are exactly the same, which it did happen. So good. We're going to rewrite one of the parentheses, and whatever we have left outside, we're going to put it together in one parenthesis. X squared minus 9. As you notice here, we have in a special case called the difference of two squares. There must be two perfect squares in order for us to factor this way a binomial. So you're going to rewrite the first parenthesis just to keep everything organized. We're going to factor this one by opening a set of parentheses. Factors of x squared is going to be x and x. One parenthesis has to be negative and the other one has to be positive. The other order of the positives or negative is not going to make no difference. Factors of 9 is going to be 3 and 3. And this has to be greater or equal to 0. Now, they want us to write the answer in set builder or interval notation. They're asking the values where our graph is going to be above. It's going to be equals or above the x-axis. picture that we have our x-axis and we have a -3. Remember, always here we have the negative infinitive and positive infinitive. 2, 1, 0 is around here. 1 is around here. 2, 3. All our exponents are 1. So we know the graph is going to be crossing in each of these points. And we have to determine where the graph is going to be above the x-axis. So for that, we're going to be checking some numbers before the first intersection, in between these two intersections, and then between 1 and 3, and then out of our range to check what is going on. So we're gonna pick some numbers. We can use easy ones like -10. Here we can use 2. 0 will be even easier. We're gonna pick 0 here, 2 here, and then here a +10. So we're gonna use -10, 0, 2, and 10. So for that, we're gonna be looking here because it's gonna be a lot easier. Just think about if we put a -10 minus 1, we don't have to solve it, we don't have to find the value, but we have to just to check. We need to check if the number is going to be positive or negative at the end. So here for sure it's going to give me a negative number. If I plug here a -10 minus a 3, for sure it's going to give me a negative number. Here -10 plus 3, the highest number is negative, so at the end the result is going to be negative. So this one is going to give me a negative number. Remember that we are looking for greater or equals to 0. So 10, we know it doesn't work. We're going to do the same thing with 0. If I plug here 0 minus 1, they give me a negative number. 0 minus 3 is going to give me a negative number. 0 plus 3 is going to give me a positive number. Therefore, -1, -3 is going to give me -4. At the end, this is going to give me a negative number that will be below 0. So 0 doesn't work either. Now we're going to try 2. If I plug here 2 minus 1, at the end it's going to give me a positive number. If I have 2 minus 3, it's going to give me a negative. And here is going to be 2 plus 3 is going to give me a positive one. At the end, as I combine them, it's going to give me a positive number. That's what I'm looking for. So 2 checks. The other number that I decided to use is -10 in here, keeping erasing by himself. Deleting, it was 10. So I'm going to try 10 minus 1. For sure it's going to be positive. 10 minus 3, the higher number is positive, so at the end I'm going to have a positive number. Here 10 plus 3 for sure is going to be positive, so 10 checks. So that gives me an idea that the graph is going to be something around here. So above the x-axis, above 0 is going to be this piece in here, the interval between -3. Question number 9. The final answer for our question number 8. Remember that we have already here -3, around here 0, 1, 2, 2, 3, And we have something similar to this going on. And we test already our answers. -10. Here we choose to use 0 and run here 2 and then 10 here. So our answer, we're going to give an interval notation. The piece that is above the interval, or that is above x-axis, which is 0, is going to be here between -3 and 1. Because we have this symbol, it means we have to use a bracket. So it's going to be from -3 to 1. That is all this piece in here. It is above 0 with the union of 3, and all this section is going to be going above 0. So it's going to be from 3 to a positive infinitive, and infinitive always goes with a parenthesis. Now we're going to go to question number 9. They want us to solve the inequality. So we're going to start by rewriting the inequality, and we have to add 1 in both sizes of the equal sign, of the inequality sign. So +1, +1, this 1 here cancel. Now we have x minus 1 over 2x minus 3 plus 1. Remember that always we have here as a denominator a invisible 1, and only writing it because I want you to see that we have an addition of fractions, and in order for us to add the fractions, we need to have the same denominator. So we're gonna multiply top and bottom by the denominator here, so we can make them to be equals. I'm gonna rewrite the first fraction, 2x minus 3 plus, and then anything multiplied by 1 is gonna be the same thing. So just gonna rewrite the binomial, and the same thing is gonna happen in the bottom. 1 times 2x is going to be 2x, and 1 times -3 is going to be -3. Now our denominator is the same, so we can combine the top. We're going to look for like terms. We have here x, and here we have 2x. I'm sorry, I should be looking at here, but it's the same thing. 2x, and then here we have a coefficient and another coefficient, 2 numbers, whole numbers by himself. So we're going to combine them. So x plus 2x is going to give me 3x. -1 plus a -3 is going to give me a -4. All that is going to be over 2x minus 3. So what I'm going to do now, this is going to be less than or equals to 0. I'm going to take both binomials, the numerator first, and I'm going to equals the, no equals, I'm going to make that to be less than or equals to 0, and then I'm going to solve by adding 4, both sizes of the inequality sign, keep saying equal sign, and 4 cancel. Now I'm going to have 3x less than or equals to 0, no, to 4. Less than or equals to 4. Now I'm going to divide by 3. Divide by 3. This cancel. Now I have x is less than or equals to 4 over 3. Now we're going to take the denominator is 2x minus 3 less than or equals to, oh, I'm looking at the main one, that's why. Minus 3 less than 0. So we're going to add 3 in both sizes of the inequality sign. Cancel. Now we have 2x less than or equals to 3. We're going to be divided by 2, both sizes. Cancel. Now we have x to be less than or equals to 3 over 2. Now to give that as an answer, an interval notation is going to be 4 over 3, comma 3 over 2. Brackets, because we have the equal sign on the bottom that goes with bracket. Question number 10. Remember the difference in this symbol is we just happen to find a closed dot. That means that we will be multiplying the two functions, but because little circle, the dot is open, that means we're going to put g into the excess of f. So I'm going to rewrite it, and I have that 1 is over, remember, g into the excess of f, so the whole g function is going to be substituting x, so it's going to be 2 over 5x minus 3. As you notice, we need to subtract fractions. In order for us to do that, we need to make the denominator to be the same. We're going to use green. That means I need to multiply top and bottom by 5x. Remember also we have that 1 in here. So we have, I'm going to rewrite the fraction. We have 2. We don't have to do anything to the first one because I have the denominator that I'm looking for. Here I'm going to distribute, so it's negative 3 times 5 give me negative 15x over 1 times 5x is going to be 5x. Now that I have the same denominator, I can go ahead and rewrite the fraction in one fraction bar. I cannot really combine them because they are no like terms, but at least I can use only one fraction bar. So I have 5x on the bottom, and on the top I still have my 1. And remember, this is 1 over 1. I cannot divide a fraction with a fraction, so what I need to do is I skip flip multiply. This will be 1 multiply, and I'm gonna flip this one, so it's gonna be 5x on the top, and on the bottom I'm gonna have 2 minus 15x. Anything multiplied by 1 is gonna be the same thing. So my answer is going to be 5x over 2 minus 15x. Now we're going to go to the next question. 11. Find the inverse of the function. This one is you follow step by step. You're going to always find the right answer. The first step is going to be change the symbol, the function symbol for y. Rewrite everything, the rest the same. Now we're going to switch y with x. So now we're going to have x equals 2 over 3y minus 7. Now in order to solve for y, that will be the next step, we need to multiply both sides by the denominator, so we can bring y to the top. Let me do it this way. Okay, this will cancel that, and we have, now we need to distribute x in both terms inside the parentheses, so it's going to be 3yx minus 7x equals to 2. Now we can move this term to the other side of the equal sign by adding 7x in both sizes. So we cancel this, and now we have 3yx equals to 2 plus 7x, and we're going to divide by 3x both sides of the equal sign, and that way we cancel 3x, so we only have y equals 2 plus 7x over 3x. The last step for the inverse will be to change the y as f of x minus 1. That is the symbol for the inverse. So that's our final answer. Now we're gonna do number 12. Question number 12. Suppose that the population of a bacteria in a petri dish is, as a function of time, is described by the following equation, which time t in units of hours. So the function is given, and letter A, what is the initial population and the population after 10 hours? So we have to remember that t is time, and it's given in hours. When they're asking us the initial population, we have to substitute t by 0. So we're going to plug in 0 in our equation, in our function. For every single t. This is really a calculator problem. We have to plug all this in our graphing calculators. Anything multiplied by 0 is going to go away, it's going to be 0. So this multiplied by 0 is going to go away, and this multiplied by 0 is going to go away. Now we have the 100 times 1 is going to be 100, and on the bottom is going to be 2. 100 divided by 2 is 50. So our initial population was 50. Now the second part of the question, and the population after 10 hours. That means we have to substitute t by 10 now. So we have 100, open parentheses, 1 plus 0.1 times 10. All that is going to be over 2 plus 0.05 times 10. Okay. Is we multiply these, the multiplication between 0.1 times 10 is going to give me 1, so 100. Here I have 1 plus 1, which is going to be 2, and the bottom I'm going to have 2 plus 0.05 times 10 is going to give me 0.5, 0.5. This 2 is going to give me 1 plus 1 is going to be 2. 100 times 2 is going to be 200. And 2 plus 0.5 is going to give me 2.5. If we divide 200 by 2.5, is going to give me an 80. So the population after 10 hours was 80. Part B. What is the maximum possible population size and why? So here is we have P of t equals 100 plus 10t over 2 plus 0.05 t a quick reminder where we got this. In order for us to find any maximum or minimum, we have to solve the original function. So what I did was I distribute 100 times 1, 100, and here 100 times 0.1, it is 10t. Just want to clarify where I got this from. And after that, we are looking for our horizontal asymptote, which will be the one giving us a limit, which one is going to be our possible maximum number. So remember that for that we have to look up at our variables and the degree. So here we have t1 and here we have t1. When we have the same exponents, what we do is we divide the coefficients. So we're going to move the decimal 1, 2 times, and that's going to give me 5. If I move the decimal twice on the bottom, I have to move it twice to the top, on the top. So that means I need to add 2 zeros. So it's going to be 1000 divided by 5. And that equals to 200. That's going to be your horizontal asymptote and your maximum. Point. Now next question. How many items must be produced each day for the average cost to be no more than $200 if the average daily cost of manufacturing items is given by the following equation, where X in units and C is in dollars? Question 13. How many items must be produced each day for the average cost to be no more than $200 if the average daily cost of manufacturing items is given by the following equation, where X in units and C is in dollars? So as we're trying to figure out the cost not to be more than 200, we have to equals our equation, substitute C, which is the cost, by 200, and we have to solve it. 32 over X. So first thing that I'm going to do is I'm going to get rid of the denominator by multiplying both sides by X. So that cancels X. Now I have 200X equals to 40x plus 32. Now I'm going to move the 200x to the other side of the equal sign. That will be better is I just do it like that. This cancel. Now here is going to be a negative 160x plus 32. This is equals to 0. Now I'm going to factor. 160 is factor of 3,200. So I'm going to pull out a negative 160 as a common factor. So negative 160, open parentheses, negative 160 divided by negative 160 is going to be 1, so I only have the x in here. No, that is going to be negative. So positive than a negative is going to give me negative 3,200 divided by negative 160 is going to give me negative, and it's going to be 20. This one I cannot equal that to 0 because negative 160 is not equal to 0, so that goes away. X minus 20 equals to 0. I have to solve for x, adding 20 in both sides of the equal sign. This cancel, I have x equals 20. And I can check my answer if that is true. I can go, that means 20 units. So my cost doesn't go over 200. As I go to the original function and I substitute the x, which x is the number of units, by 20, I have 40. I'm going to substitute all my x's by 20, 3200. All this divided by 20. I like to keep everything organized. So 20 times 40 is going to give me 100 plus 3200. All this over 20. I'm doing a step by step. You can put everything at once in your graphing calculator. That is going to give you 4,000 divided by 20. It's going to give you 200. So for 20 units, it's going to be your cost $200. That checks. Good luck.